Okay, so today we're going to talk about two different theorems that we're learning. The first one's going to be the irrational root theorem, and then the imaginary root theorem. And then we're going to use these, and we're going to be given roots, and then we're going to be asked to write the standard form that has those roots. Okay? So one thing that you should notice as we moved along through solving these polynomials, and whenever we obtained irrational or imaginary solutions, there was a pattern that developed. First of all, with irrationals, remember irrational numbers are like the square root of 2, pi, things like that. It's a decimal that keeps on going on and on and on, and we don't know the end to it. So we don't know the last digit of pi, nor do we know the last digit of square root of 2. Some people might say like 1/3 is an irrational number because it keeps repeating, but if you think about it, the last term of 1/3 would be a 3, so you know the end of it, so that'd be a rational number. Okay? And the irrational root theorem, just to sum it all up, says that if you have a root that's an irrational number like one of these, they come in pairs. So an example would be if they tell you your root is square root of 2, you can assume that you're going to have a root at negative square root of 2. Okay, so here are some examples. If they tell you you have a root at square root of 5, you can assume that you're going to have a root at negative square root of 5. If they tell you you have a root at 1 plus square root 3, you can assume you have a root at 1 minus square root 3. So these always come in pairs. And that's the irrational root theorem. And the same thing works with the imaginary root theorem. They also come in pairs. So if you have a root at 2i, you're going to have one at negative 2i. Or if you have a root at negative 3 minus 4i, you're going to have another root at negative 3 plus 4i. Okay? Notice that the sign only changes with the irrational number and the imaginary. The real part here and the leading number there stay the same. Okay? Okay, so we're going to look at some examples here. They're going to give us the roots, and then they're going to want us to write or find the standard form of the equation. Okay? So first one we're going to look at here is they're going to tell you the roots are at square root 2 and let's say 3i. So they tell us there's roots here, and they want us to write this in standard form. So find the standard form of this polynomial. And make sure you're getting some paper so you can write this too. Okay? So first of all, since we know there's a root at square root 2, using the irrational root theorem, there also has to be one at negative square root 2. And using the imaginary root theorem for 3i, there has to be one at negative 3i. So you should be thinking to yourself, okay, now I have 4 roots. That means that we should have a polynomial to the 4th degree. So if we get something at the end that's to like the 10th degree, pull the emergency brake. We did something wrong. And now we'll kind of go backwards from when we solved these polynomials. So these are our roots. So we know at the end of it, we would have had something like this. After we factored and solved. Then the next step to get us to here, well, we could just bring all these over to the other side of the equation. So plus square root 2. So x plus square root 2 equals 0. And then I'll do the same thing for all of these. So hopefully you kind of see in your head, if you were to go this way, this would have been the order that you would have went to solve it. Okay, and then to get to this part, to use that zero product property, we had to multiply all these factors together. Okay. So sometimes it's easier with this too. Like when you went to do this, let's say you You want to kind of match the pairs up together when you're multiplying. Makes your life a little bit easier. You don't have to, but it makes your life easier. All of these are being multiplied together, so we have to double distribute. But to be smarter, I'm going to distribute these two together, and then I'll distribute those two together, and then distribute their products. So distributing this one, x times x gives me x squared. X times negative square root 2 is negative x square root 2. And then take these guys, you get a positive x square root 2. And then square root 2 times square root 2 is just 2, and it's a plus and a minus, so minus 2. Okay? Then I'll do the same thing to these two. X times x, x squared. X times 3i plus 3i. Then do these guys here. Minus 3i minus 9i squared. Now the nice thing about this, look inside your parentheses here, and you see negative x squared 2 plus x squared 2. These guys cancel out. Sum up to 0. And the same thing happens here. Sum up to 0. So now I'm left with x squared minus 2 times x squared minus. Now, 9i squared, one thing we remember from the previous, lessons, I squared equals negative 1. Okay, if you need help with that, look back at the previous videos. So we're going to make this substitution for I squared there. So I get x squared minus 9 times negative 1. It's not negative 1 squared. I squared equals negative 1. So you replace that with negative 1. Okay? And then making this look nicer, x minus 2 times x squared plus 9. Okay? Now we can double distribute this guy. I'm going to run out of room. Oh, sorry, that's an x squared. So I'm going to start writing over here. X squared times x squared is x to the 4th. X squared times 9 is plus 9x squared. Negative 2 times x squared minus 2x squared. And then negative 2 times 9 is minus 18. Combine like terms. We get x to the 4th plus 7x squared, that was all equal to 0, minus 18. And we set it equal to 0, but remember we're looking for the equation, so we set this equal to y. There you go. So you should see in your head, let's say you were to start with this, you would factor and you kind of work your way backwards to getting your roots. So when you're looking for that standard form, you're going to get your roots and then work your way to get this. Okay? Okay, let's have you try one. So after I erase this, pause the video, try it out. Again, you're going to find the standard form of this. Okay? Let's just say you have, let's say you have a root at square root 6. So pause the video, try this out, and then come back. Welcome back. Okay, if you know you have a root here by the irrational root theorem, you also have one. Okay? So we should be looking for a second degree polynomial or a quadratic. So again, do what we did last time and start working backwards. Then the step before this, x minus square root 6 equals 0. X plus square root 6 equals 0. Take the products, x minus square root 6, x plus square root 6. Double distribute, x squared plus x root 6 minus x root 6 minus 6. Look at earlier videos if you have trouble with that. These, x squared minus 6 equals y. Okay. The nice thing about these always cancel out like that, so life is good. So you do need to have, they call them integral coefficients for these, but we're not really going to throw you a curveball and give you anything that's like that. Okay, so this is the first part of these guys, first video. Hopefully you feel good with these. Watch the next video where these get a little bit more complex, but it's the same idea.